Welcome, and in this lesson, we're going to talk about hard links and soft links on a Linux Red Hat system. Now, first, let's be introduced to what links are. Links are exactly what they sound like. They link to another file on the system. Now, there's two types of links. We have a symlink, often referred to as a symbolic link, and a hard link. Now, if I navigate into my etc directory, then into systemd, and then go inside of my system directory, and I do an ls, there's actually symbolic links inside of here. How do I know that? Well, I know that because if I type my ls-al, so I can get my all and long listing details, what I see here is I see symbolic links. Now, what happens is this is saying dbus.org.bluez.service actually opens this file. Now, symlinks are very useful in terms of this is just a link. So I can reference this file and it will actually redirect me to here. It's as if I'm using the same service location. And you'll notice that a lot of times our Linux system is made up of symlinks to other locations on the system. So what were to happen if I were to go ahead and just open up this default target right here? If I were to do a vim default.target. Well, what's happening is it's really opening this location here. It's opening this file inside of lib systemd system multi-user.target. Now, what I'm going to do is I'm going to go ahead and head back into my user's home directory. I am operating as the root user, and let's go ahead and create our first symlink. Right? So to do that, I use the ln command. The ln command is used for creating both symbolic links and hard links. By default, if I don't pass an option or a flag, they're the same thing, it's going to create a hard link. So to create a symlink, which is more commonly used in Linux environments, I'd type a -s. And then I would specify my target. My target, let's say, is the etc motd file. And then let's name my link name, motd. So if I do an ls-al, what happened? And again, I can just do an ls-l for long listing, which provides more details. The a just lists all. So we created a link called motd. This link opens the etc motd file for editing. So if I do a vim motd, I'm really opening the file that's located inside of my etc directory. So I could edit this file, save and exit, and I could cat the etc motd file. And you'll see that we've just edited that file. Now, what would happen if I removed my source file, etc motd? I'll just go ahead and move the etc motd file, and I'll move it and just rename it to etc motd1. Now, if I type my ls-l, we see it's red. What we have here is we have a broken symlink. If I try to edit this file, I'm actually going to be editing a new file on the system. I can save and exit on that, do an ls-l, and what would happen is it would actually recreate our etc motd file. So it's broken, but when we edit this symlink, it's still opening this location. Right? So if we were to take a look at our etc motd file, you would see that there's the contents of the file that we've created. Now, a few considerations for symbolic links. They can be broken if the source target is moved or removed. But again, because this opens up this location, I could just go and recreate the file. But a broken link could cause an issue depending on where you have symlinks on your system. When you edit a symbolic link, you're essentially opening the source location file for editing. You can have any number of multiple symlinks to the same file on the system. So for example, ln-s, I'm going to link to the motd file, and I'm going to call it motd1. Do a long listing. I can view that they both go to the same file on the system for editing. This is just a link. I can cat the motd here, and it's just going to be showing the contents of etc motd because it's a link to the etc motd file. Now, one thing that we also need to be aware of, I don't have another file system attached to this right now, but we could attach one for our Linux Academy Lab server, format it, but we're not going to do that. Just know that you can if you want, but we only would do that to prove that symbolic links can link across file systems because it's just a symbolic link to another file. It's not editing the inodes that store the data on the hard drive. It's just a link to another file. It's a shortcut. So if you're familiar with Windows shortcuts, that's all it is a Windows shortcut on your system. Or, I mean, it's not a Windows shortcut, but it works exactly like a Windows shortcut on your system. So what about permissions on a symbolic link? So if I did an ls-l and I looked at these permissions, you would say, all right, this is world executable. That means anybody could technically edit this MOTD file, even though if I did an ls-l in the etc directory and did a grep for my MOTD file, we could see that, well, only root would have permissions to read and write this file. So what happens if I exit out of the root user and I'm inside of my regular users directory? So even though it looks like I have permissions, what happens if I try to edit the MOTD symlink? Well, the symlink has world permissions, everything readable for it, just so we know where it's going. But if we were to try to edit that, we can't. You notice here it says, warning, changing a read-only file. Now, the source file itself did have read permissions for everybody else, as we see here. But it did not have write permissions, and so that's why I was unable to do that. So really, when you see these permissions on a symlink, because this is just a symlink linking to another file, we're looking at permissions on the symlink. So these permissions do not matter. Instead, the source permissions on our target file is what the system reads when opening the link. So even though it might look like the user has permissions to edit, the user doesn't really have permissions to edit. So let's talk about hard links. Hard links are a link to a specific inode location on your file system. On a file system, an inode provides information about files and directories. Now, this is the reason that hard links can't link across file systems, because you're linking to a specific inode, where you can't link to a different inode from one file system to another file system. Now, symlinks you can, because you're just creating a shortcut to a location on the system. But a hard link is linking directly to the inode. So if I were to type an ls-l, my first column here, I see this is the number of files or links to that specific inode. This right here links to the same inode in two different locations. Same here with this one. So let's go ahead and create our first hard link. To do that, I'm just going to use my ln command. Instead of passing it my -s option, I'm just going to do my target, and I'm going to target the VNC how-to, and I'm going to call it VNC lowercase how-to, because it's case sensitive inside of Linux. These are two different files because of case name. That's actually something that you need to be aware of. So if I type ls-l, we now see here that instead of one link to the same inode, there's two links to the same inode. Well, this is indicating to me that both of these link to the same inode. Now, it doesn't have to be in the same directory. We see that there's other links to the same inode, but we don't see those linked in here. So what we're able to do is I can cat VNC how-to, and we can see the contents, and I can cat the lowercase VNC how-to and see the contents. So what happens if I were to echo a command in there? I'll say echo hello world into VNC how-to. Clear my screen so we can read it. And let's cat our VNC how-to. Well, it's on the lowercase one. Let me cat the uppercase VNC how-to. And it's also there because we're modifying inode information. So that's what a hard link is. It links directly to the inode on the file system. So again, let's go over a few considerations for the inode. How do you think permissions work? Well, with permissions, since permissions are applying to that data, it's not going to work the same as it does with symlinks. With symlinks, our permissions don't matter on the symlink. It's going to open the file that it's opening. But instead, what happens if we were to change mod, which is changing permissions, 777, on one of these files? You'll see that it changes it on both of them. Basically, we're changing that inode permissions or permissions on the inode to the specific data. Since it applies to the file system, we're applying those changes. So whenever we make permissions to one file, it's going to be applied to the other file. So we changed it on the source file. What's going to happen if we change permissions 000 on the new link file? Well, let's change that and see what happens. It's going to change it on both of them because it's applying it to the inode. What happens if I remove our original source file, our target file? What happens then? Well, we know what happens with the symlink it becomes unavailable. Basically, the symlink breaks. So if we remove the target file here, will we still be able to view the contents inside of a hard link file? And the answer to that question is yes, we will. So because it's linking to that same inode information, as long as there's something linking to that inode information, it will still be there. So let's sum up considerations for hard links. Hard links link directly to the inode source on the hard drive. If the source or target file is removed, the created link still exists and the data is available on the inode until all links to that inode are no longer available or no longer exist. All hard links linking to the same file will have the same date times as well as permissions, both of those. After a new hard link is created, it is not possible to determine which one was the original file. As we saw from here, there's no way to distinguish that. And then again, we can use ls-l to view both hard link information and symlink information. So that concludes it for this lesson. Go ahead and complete this lesson and move on.